Hello students, this is Sushil Misra and we are continuing with the previous lecture. This is complex number part 2 and the question is written express 5 plus root 2I upon 1 minus root 2I into a plus ib form. So let us start how to solve this question. So let us take this is 5 plus root 2I upon 1 minus root 2I. We need to rationalize this. Rationalization you all must be knowing that we need to multiply with the 1 plus root 2I upon 1 plus root 2I. Rationalization means we need to remove the root values from the denominator. So this will be continued. 5 into 1 5 plus 5 root 2I plus root 2I plus root 2 into root 2 2I into I square. Here I am writing I square upon in denominator always a minus b, a plus b, a square 1 square minus b square. Okay, so this will be 5 plus 5 root 2I root 2I 1 root 2I 5 root 2I 6 root 2I plus 2 into I square. Yesterday we learned minus 1 upon, similarly 1 square is 1 minus root 2 square is 2 and I square is minus 1. So this will give 5 plus 6 root 2I plus minus 2 upon 1 plus 2. So this will give 5 minus 3 plus 6 root 2 upon 3. Further solving, 3 can be taken as common, so 3 will be common. 1 plus 2 root 2 upon 3. This 3 will cancel out. So 1 plus 2 root 2 I. Here I forgot to write I. This will be I. Sorry, here inside I root 2I. So which is in the form of a plus b. So therefore a equal to 1, b equal to 2 root 2. Generally we don't need to show the value of a and b. We need to put in the form of a plus ib. You can see this is in the form of a plus ib. Okay. So this will be the answer. This is the method to represent any number. If it is in denominator in fraction, then we need to take the rationalization process and further on solving we will get the answer. Now let us start other question. We can take the other question, multiplicative inverse. One or two questions are of multiplicative inverse. So very simple one I am taking. Question is, find the multiplicative inverse of question is 2 minus 3i. Suppose this is the question. This is the question, multiplicative inverse. Generally in the previous classes we have studied the multiplicative inverse of any number is the number on which multiplying the given number result should be 1. If suppose number is a, if you will multiply with 1 by a will cancel out, the answer will be 1. If number is minus a, then we need to multiply with minus 1 by a will cancel, minus will be plus 1. The result should be plus 1. It means on reciprocating the number, we are getting the required number. So let solution, how to solve. Let a plus ib, okay, a plus ib be the multiplicative inverse of 2 minus 3i. Therefore, if you multiply a plus ib with 2 minus 3i, result should be equal to 1. So a plus ib must be equal to 1 upon 2 minus 3i. Again, as you know, we need to rationalization process you all must be knowing. So this will be 1 multiplied by the any number is number itself. So 2 plus 3i, a square minus b square. So this will be 2 plus 3i upon 2 square is 4 minus 3 square is 9 and I square is minus 1. So 2 plus 3i upon 9 minus minus plus 4 4 13. So this can be written as 2 by 13 plus 3 by 13i. So this will be the final answer. This will be the final answer of the multiplicative inverse. Formulas are also there, but I think so this is the easiest way to find out the multiplicative inverse. Okay, so this will be very easy for you, I think so. And now formula for multiplicative inverse. Okay, formula for multiplicative inverse: conjugate and root over a square plus b square. Z bar, as you know, 2 minus 3i, 2 plus 3i z bar. We have studied conjugate. Only the sign of imaginary part will get changed. So z bar will be 2 plus 3i and root over a square. A square means 2 square, b square means 3 square or minus 3 square. Okay, look. And 2 plus 3i upon root over 4 plus 9. 2 plus 3i. The formula root is not there. That root in modulus only. Okay. Likewise this a square plus b square. So this will be 13. So can be 2 by 13 plus 3i by 13. So this is the another way to find out the finding out the multiplicative inverse. Formula again here you can see mi z bar means conjugate of the given complex number upon a square plus b square. That will be, generally it is written as like this, r square. Okay, r is what? A square plus b square. Further you will study, that's why I have written a square plus b square. Okay, so this is the way to find out the multiplicative inverse. But for every question this is suitable, and rationalization it will help you. In the previous questions we have seen, we need to know how to rationalize the complex number, so it is better to go with this method. Okay, so this is the way to finding out the multiplicative inverse. Now modulus. Now one modulus question we are going to solve. So question, again we are taking one question, find out the modulus. So question is, find the modulus of 1 plus I upon 1 minus I minus 1 minus I upon 1 plus I. This is, so solution: 1 plus I upon 1 minus I minus 1 minus I upon 1 plus I. Directly we can start with the LCM, it is better. Firstly simplify. Okay, minus minus will cancel out, so 1 plus I whole square minus plus plus will cancel out, so 1 minus I whole square. So a square 1 plus b square I square plus 2ab 2i minus then a square 1 plus b square I square minus 2ab. A plus b, a minus b, so 1 square minus I square. This will be 1, I square is what? Minus 1 plus 2i minus bracket 1 plus, then minus I square is minus 1 minus 2i. Plus minus will cancel out, plus minus will cancel out, and here 1 and I square is minus 1, this minus and minus plus 1. So this will be what? 2i, this minus minus plus 2i upon 2. 2 can be taken as common, or likewise 2i 4i upon 2. 2 to the, this will be 2i. On simplification we got 2i. Now modulus, mod z is what? Root over a square plus b square. It can be written as 0 plus 2i. Okay, don't be confused. 2i can be written as 0 plus 2i. So here a is what? 0 square plus b is what? 2 square. So this will be 4 and this will be 2. So this will be your final answer. How to find out the modulus? Modulus is generally this, but your given question should be in the form of a plus ib. So further we need to simplify this. We did the simplification. 2i we got, that can be written as 0 plus 2i, and now mod z equal to root over a square plus b square, that is 4. 4 and root over 4 is 2. So this is the way to first question. In first question we find out the how to write the complex number in the form of a plus ib. In the next question we went for multiplicative inverse, and then this third question we went for modulus. I think you understand. For any doubt you can ask your doubts. I'll be there to solve out your doubts, and kindly like and subscribe channel for the further video. Thank you.